Welcome to this detailed video on polarization, a key topic for the exam. In this video, we'll cover the nature of light as an electromagnetic wave, the different types of polarization, methods to achieve polarization, and important concepts like Brewster's Angle and Malus's law. We'll also explore the applications of polarization in real-world scenarios. So let's dive in. Light is an electromagnetic wave, which means it consists of oscillating electric and magnetic fields that are perpendicular to each other and to the direction of propagation. This makes light a transverse wave, where the oscillations occur perpendicular to the direction the wave is moving. Understanding the nature of light as an electromagnetic wave is fundamental to grasping how polarization works. In transverse waves, such as light, the oscillations of the fields can be oriented in various directions, leading to different forms of polarization. There are three main types of polarization. The first is linear polarization. Here, the electric field of the light wave oscillates in a specific direction, creating a uniform orientation. The second is circular polarization. In this form, the electric field rotates in a circular motion as the wave propagates, creating a helical pattern. Circular polarization can be right-handed or left-handed, depending on the direction of rotation. The third is elliptical polarization. This is a more general form, where the electric field traces out an ellipse. It combines the characteristics of both linear and circular polarization. Now, each type of polarization has unique characteristics and applications, making it essential to understand their differences. Now, there are several methods to achieve polarization of light. The first is through polarizing filters. These are sheets or filters that allow only light with a specific polarization to pass through. Unpolarized light, which has electric fields oscillating in all directions, become polarized after passing through these filters. The second is reflection. When light reflects off a surface at a specific angle, known as Brewster's Angle, it becomes completely polarized. This phenomenon is why glare off water or glass surfaces can be reduced using polarized sunglasses. The third is scattering. Light can also become polarized through scattering, as seen in the atmosphere. This is why the sky appears blue. Shorter wavelengths of light are scattered more and become polarized, while longer wavelengths pass through more directly. Understanding these methods is key to grasping how light can be controlled and manipulated in various applications. So Brewster's angle is the angle at which light reflected from a surface is completely polarized perpendicular to the plane of incidence. At this angle, the reflected and refracted rays are perpendicular to each other, and the reflected light is fully polarized. Brewster's angle can be calculated using the following equation, where N1 and N2 are the refractive indices of the two media. This concept is particularly important in designing optical systems where polarized light is needed, such as in photography to reduce glare. Malus's law describes the intensity of polarized light passing through a polarizer. The equation is given by I equals I0 cosine squared of theta, where I is the transmitted intensity, I0 is the initial intensity, and theta is the angle between the light's initial polarization direction and the axis of the polarizer. This law is crucial for understanding how the orientation of a polarizer affects the amount of light that passes through. It's used in various applications, such as adjusting the brightness of LCD screens and in polarized sunglasses. Now, polarization has several practical applications. The first is optical activity. Certain materials, like solutions of chiral molecules, can rotate the plane of polarization of light passing through them. This property is used to measure the concentration of substances in both chemistry and biochemistry. Second would be polarization sunglasses. Polarized sunglasses reduce glare by blocking horizontally polarized light, which is commonly reflected off surfaces like water or roads. And the third is 3D glasses and imaging. Polarization is used in 3D movies and imaging techniques. Each lens of 3D glasses filters light polarized in a specific direction, allowing each eye to see a slightly different image, creating a three-dimensional effect. These applications highlight the importance of polarization in both everyday life and advanced technologies. Birefringence, or double reflection, occurs when a material like calcite splits a light wave into two rays, each with a different polarization. These rays travel at different speeds and take different paths through the material. This property is used in various optical instruments to analyze the properties of materials, especially in crystallography, and in studying stress patterns in transparent materials. Now, let's consider the types of passages you might encounter on your exam based on these topics. You could see a passage discussing optical activity where you'll need to apply your understanding of how polarized light interacts with chiral molecules to determine the concentration of a solution. Another passage might describe a scenario involving Brewster's angle, requiring you to explain how polarized sunglasses reduce glare by blocking light reflected at this angle. So to excel on your exam, it's crucial to master the following key points. Number 1. Light is an electromagnetic wave that can be polarized, with electric and magnetic fields oscillating perpendicular to each other in the direction of propagation. The second is that there are different types of polarization: linear, circular, and elliptical, each with unique characteristics and applications. And the third is that polarization can be achieved through filters, reflection, and scattering. Understanding Brewster's angle and Malus's law is essential for calculating polarization effects. So in summary, understanding polarization is essential for mastering concepts in optics. By grasping these principles, you'll be well prepared for your exam and future studies. And if you found this video helpful, don't forget to like, comment, and subscribe to our channel for more educational content. And if you're in the app, please make sure to like the video there. Your support helps us continue to create these informative videos to aid in your study journey.